Good morning. I'm going to take a few minutes today to work our way through the Appendix A Connect homework Part B. And so what I want to do is make sure that we establish there's kind of two phases to what we're working with. The first phase is being able to write the objective function, define the variables, and then write the constraints. And then the second phase is to take that information and understand how we need to put that into Excel and use Solver to solve for our solution. Okay, so the first thing we're going to do is we're going to take this problem A1, right? And they've pretty much given us the objective function and the constraints for resource A, resource B, and resource C. And I want to walk you through how you should consider what we're saying. So we're saying we're going to maximize Z. So we know that that means we're either maximizing profit, sales, revenue, right? Something that we want more of, okay? And we're going to assume that X and Y are products that we're going to produce. And so our objective function, 3X plus Y, we can restate that 3X plus 1Y, because that would be the coefficient for Y, means that for every X that we sell, we're going to get $3 of profit. For every Y that we sell, we're going to get $1 of profit, okay? As far as the resources go, for every X that we're going to produce, we're going to use 12 of resource A. And for every Y that we're going to produce, we're going to use 14 of resource A. And we only have 85 of resource A available. So we can't use any more than 85 of that particular resource. And in the same way, 3X plus 2Y less than or equal to 18 for resource B says we have, for every X that we produce, it's going to take 3 of resource B. And for every Y that we produce, it's going to take 2 of resource Y. And we only have 18, so we can't use any more than 18. And for each Y, right, that we produce, it's going to take 1 of resource C, and we only have 4 of those available, okay? So in this particular instance, I'm going to go ahead and kind of share the screen here while we work out how we're going to put this together. So we're going to start by saying the objective function. And I usually describe the products here, but we only have information about X and Y. And I know I like to have everything centered. So I go ahead and just set everything up to be centered from the get-go. Okay. And we know when we use Solver that we need to tell Solver what cells do we want it to put, how many of X we're supposed to produce and how many of Y we're supposed to produce when we maximize, in this case, our objective function. Okay. And we're going to maximize this objective function. And every time we sell an X, we're going to receive, we get 3 in profit. And every time we sell a Y, we get 1 in profit, okay? And then what I do here is we have to have some place for Excel to actually run the calculation. And I showed you yesterday that we like to use something called the sum product, and I can hit an array. So I'm going to do this array of these 2 cells, and I'm going to go comma, and then I'm going to multiply it by these 2 cells, right? And so what sum product actually does is it takes cell B2 times cell B3, and then adds to it the product of cell C2 times cell C3, right? So, and again, this is when we say we want to maximize the objective function, this is where the value of that, when we have our final solution, comes into play, okay? And then subject to the following constraints. And in this problem, we have resource A, we have resource B, and we have resource C. Okay. And I have told you that we must write the constraints with using the same variables that we have in the objective function. Okay. So for resource A, it takes 12 units of resource A to produce an X, and it takes 14 units of resource A to produce a Y. it takes 3 units of resource X to produce, excuse me, takes 3 units of resource B to produce an X, and it takes 2 units of resource B to produce a Y. It takes 0 units of resource X to produce 0 units of resource C to produce an X, and 1 unit of resource C to produce a Y, okay? And we want Excel to be able to tell us our constraint value, right? In terms of, let me rephrase that. We want Excel to be able to determine that we have not exceeded our constraint value. So I put in our constraints and I leave a gap here where I can calculate based on whatever solution Excel comes up with, how many of those constraints are we actually going to use? So I'm going to use my sum product, and I'm going to take my changing cells. I'm going to fix my cell reference to them, because for resource A, B, and C, I always want to go back to how many X's and Y's we're going to produce. And then I want to multiply that by the amount that each of those products uses of resource A. Okay. And because I fixed that cell reference, I can just copy that down. So again, what this is doing, it's going to take however many X's we produce times 12 plus however many Y's we produce times 14. And it's going to tell us what that value is. Now I feel like I'm done setting up and I can solve, but I like to check first. So if I make 1 X, I should see 3 in profit, 12 units of resource A used, 3 units of resource B used, and 0 units of resource Y. I also want to check Y, and I have 1 unit of profit, 14 of resource A, 2 of resource B, and 1 of resource C. So all of that looks like it's working. So now that I have this set up, I'm going to go ahead and run solver. Okay, and so I go data, solver. Here's my cell that I'm optimizing, and we want to maximize that by changing these 2 cells. I'm going to add in my constraints. And because these are all the same sign, I can say all of these 3 values need to be less than or equal to these 3 values. So my right-hand side of my constraint is the resources used. I'm making them non-negative, and I'm going to use simplex LP to solve. And when I hit solve, it comes back and tells me, do I want to keep this solution? I'm going to say okay. So it tells me I'm going to make 6 X's, 0 Y's. I'm going to use 72 of resource A, 18 of resource B, and 0 of resource C. Now let's check that against 6, 0, and $18 of profit. That looks right. I'm going to use 72, 18, and 0. That comes from these 3, right? So it looks like we've done correctly. The other thing I'd like to do is I should label this resources used and resources available. Okay. Back to home in the wrap text. Okay. So that finishes our first problem in B, right? Now let's go ahead and look at our second problem in B. And our second problem gives us a word problem that we have to kind of write our information for, okay? I'm gonna go ahead and take this and put it over into Excel. Now in class, I did this on the board, but here, I won't. So I'm gonna go here, text, there we go. And we'll increase that so everybody can read it. Okay. The way that makes sense for me to do a linear programming problem is to read the entire problem and then to write the objective function. And then out of the objective function, the other things that we need to have come into play. So we need to state the objective function. We need to define the variables. We need to state the constraints, including non-negativity. And then if we are doing our homework, we need to use solver to find the solution. Okay. So the first thing I'm going to do is I'm going to state the objective function. And you know what? I don't have to make another line for that. We can just come right here. So to state the objective function, and this is if I'm handwriting on an exam, I would read this and I'd say, Seatown Brewery brews 2 beers, Expansion Draft and Burning River. Expansion Draft sells for $20 per barrel, while Burning River sells for $8 per barrel. Okay, I've come across a keyword that tells me I know what my objective function is. I'm talking about sales value. Okay, and in a problem, you should be looking for sales value, profit, right? We should be looking for cost. So we're maximizing sales value, we're maximizing revenue, we're maximizing profit. If it's cost, then we're minimizing. Okay, so my objective function is going to be to maximize Z such that, and I like to use variables that help me remember what I'm talking about. So for expansion, I'm going to put 20E, because it's $20 for each barrel of expansion, plus 8B, which is $8 per barrel of Burning River. Okay, now to define the variables, I'm going to go, okay, my variables are E and B. So E is the number of barrels of expansion draft while B is the number of barrels of Burning River. Okay, so now I have defined my variables. Now I need to state my constraints. So I'm going to finish reading the problem. So producing a barrel of expansion draft takes 8 pounds of corn and 4 pounds of hops. Producing a barrel of Burning River requires 2 pounds of corn and 6 pounds of rice and 3 pounds of hops. The brewery has 500 pounds of corn, 300 pounds of rice, and 400 pounds of hops. Okay, this last statement is my best clue for what my constraints are, because it's telling me this is all I have of these resources available. So in our last problem, corn would have been resource A, rice resource B, and hops resource C. Well, now we can just label them, right? Because we actually know more about that resource. So my constraints need to be written in the same terms, same variables of E and B, okay? And so when I write this constraint for corn, that constraint is going to be the coefficient of how many resources of corn it takes to produce an expansion draft. So expansion draft sells for $20 per barrel, while Burning River sells for $8 per barrel. Producing a barrel of expansion draft takes 8 pounds of corn. So it's going to be 8E plus how many pounds of corn for Burning River? 2 pounds of corn. And we know that we only have 500 pounds of corn. Okay, my next we've got corn, rice, and hops, right? Okay. And for rice, I know that for each barrel of rice, it takes, excuse me, for each barrel of expansion draft, it takes 0 resources of rice. And for each barrel of Burning River, it takes 6 pounds of rice. Okay, and so then that has to be less than or equal to, we only have 300 pounds of rice available. And for our hops, for each expansion draft, right, it takes 4 pounds of hops. So 4 for each E plus 3 for each B, right? Because it's 3 pounds of hops for Burning River. And we have available 400 pounds of hops. And I would also need to write the non-negativity, which would be E, B has to be less than, or excuse me, has to be greater than or equal to 0. So now I've written my constraints, okay? So on an exam, this is what you would be writing into how do I set up a problem? Because as I stated in class, we don't have access to Excel during the exam. So what I'm going to do is give you a problem and have you write the setup, just like what we've done here, where you state the objective function, define the variables, and then state the constraints, okay? All right, that being said, the next and last step is to set this up in Solver, okay? So what I'm going to do that is we're going to kind of do a little cheat here. We're going to come back. We've already set this up for 2 variables, right? So, but instead of X and Y, we're going to have E and B, right? And then I'm going to go ahead and go next door here. Let me blow this up so it's a little easier to read. And we're going to grab this information because that's what we need to put into Excel Solver. And so I have E and B, and my objective function is 20 sales dollars for each E and 8 for each barrel of Burning River, okay? And so then in terms of E and B, instead of resource A, I have corn, and I have rice, and then I have hops. I need to put in my coefficients, 8 and 2, 0 and 6, 4 and 3, right? And I need to update my resources available to 500, 300, and 400. Now, that works great when I have the exact same amount of variables and the exact same amount of constraints that I did on the last problem. And so all I need to do is come back to Solver and go Data, Solver. And I want to maximize D3 by changing B2 and C2 with the following constraints. The resources used for corn, rice, and hops have to be less than or equal to the resources available. And say OK. Make non-negative, we'll use simplex LP. We're going to solve. I'm going to say OK. And it comes back and tells me I need to produce 50 of expansion draft, 50 of burning barrel for a profit of $1,400. And it tells me that I'm going to use 500 corn resources, 300 rice resources, and 350 hops resources. Now let's do a quick check of that against our response here. 50, 50, 1,400, 500, 300, and 350. There you go. All right. The other thing I wanted to talk about, and we talked about this in class, is making sure that you understand what slack resources are. So slack is the difference between what I have available and what I've actually used, okay? And you can see that I've used all of my corn, I've used all of my rice, but I have 50 pounds of hops left over. That means that corn and rice are what we call binding resources because we're not able to produce any more of what we would want to produce because we don't have any more corn or rice available, okay? All right, let's look at the last problem for this one. And it is a little different because we're going to, we have more variables in this one. All right. So a farmer in Wood County has 900 acres of land. She's going to plant each acre with corn, soybeans, or wheat. Each acre planted with corn yields a $2,000 profit, with soybeans yielding $2,500 profit, and wheat yielding $3,000 profit. Choose 100 workers and 150 tons of fertilizer. The table below shows the requirements per acre for each of the crops. Okay, well, a couple of things. Again, where I like to go is I like to look at this as my objective function, right? I can find right away that each acre yields 2,000 profit for corn, 2,500 for soybeans, and 3,000 for wheat. All right, so I'm going to go ahead and come back and we'll share half the screen again. So, and what I might do on this one is kind of down below where I normally am going to need to use spaces. Go ahead and copy in this table. So I've got that table, but actually I'm going to do something a little different. We're going to come back here and we're going to copy our expansion draft one, and we will revise it. Okay, so I know that I have corn, I have soybeans, and I'm going to have wheat. Okay, so as I write, I need to state my objective function, and we know that it's going to be for each acre of corn, it's going to be $2,000 in profit. For each acre of soybeans, it's going to be $2,500 in profit. And for each acre of wheat, it's going to be $3,000 of profit. Okay, so then I'm going to say C is the number of acres of corn to plant. S is the number of acres of soybeans to plant. And W is the number of acres of wheat to plant. Okay, so I need to state my constraints in terms of corn, soybeans, and wheat, because that's the variables for my objective function. And my constraints are labor, fertilizer, and there's one that's maybe not quite so obvious, but it's the number of acres that we're going to plant. Okay, because we know we only have 900 acres to plant, so we need to tell Solver that we can't exceed those 900 acres. Okay, so my constraint for labor, right, is going to be, it takes 1/10 of the labor for each acre of corn, plus 3/10 of a laborer for each acre of soybeans, right, plus 2/10 of a laborer for each acre of wheat. And we know that we only have 100 workers available. And for fertilizer, it's 2/10 of a ton of fertilizer for each acre of corn. And we're going to add to that 1/10 for each acre of soybeans and 4/10 for each acre of wheat. And we only have 150 tons of fertilizer available. Okay. And then for acres, every time I plant an acre of corn, I need to count it. Every time I plant an acre of soybeans, I need to count it. And every time I plant an acre of wheat, I need to count it. And that needs to be less than or equal to the 900 acres. Okay. So I have now done what I need to do on an exam, which is state the objective function. I define the variables and state the constraints. I need to change that non-negativity to be C, comma, S, comma, W. Okay. All right. So now I need to revise out just so we can see that a little clearer. my formulas, because if you note, my sum product only does for those two variables. So I need to change that to be, okay, I need all three of these, and I need all three of these. Boom. So I've revised this. I need to restate my objective function in terms of corn, soybeans, and wheat. 2,000 profit for each acre of corn, 2,500 for each acre of soybean, and 3,000 for each acre of wheat. Okay. And again, restating my constraints for labor, fertilizer, and acres. Okay. So for corn, it's 0.1, for soybeans, it's 0.3, and for wheat, it's 0.2. For corn, it's 0.2, soybeans is 0.1, and wheat is 0.4. And acres, just every time we plant an acre, we need to count it, okay? And I have 100 resources available. 100 for labor, 150 tons for fertilizer, and 900 acres, okay? So just to do the quick check, I should come back to my changing cells and test out, well, what if I only produced 1 acre of corn and nothing else? I should see 2,000, 0.1, 0.2, and 1, and I do. And what if I only produced 1 acre of soybeans? I should see 2,500 in profit, 3/10, 10, and 1, so that all looks good. And 1 acre of wheat says 3,000. Now see, this is why we do that. I didn't change these, did I? So I've got to change this to represent all of those, and this to capture all of those. And then I can copy it down. Boom, boom, boom. And so now when I do 1 acre of wheat, I see 3,000, 2/10, 4/10, and 1. Okay. So we've got everything updated. We're going to go data, solver, maximize by changing this, by changing these cells and adding the constraints that the resources used have to be less than or equal to these resources that are available. And we're going to say, okay. I'm going to use simplex LP, and we're going to solve. And go ahead and turn this into dollars. Tells us that our profit is 1,650,000, and plant 700 acres of corn, 100 acres of soybeans, and no wheat. Let's see how that compares with 700, 100, 0, 1,650,000, using 100 laborers, 150 tons of fertilizer, 800 acres planted. Okay, so that's your walkthrough of homework